Ladies and gentlemen, let's go back to our first definition of a derivative. Fx equals f of x minus f of c minus x minus c. Remember, that gives us, remember when we talked about this, we were doing like some function that was like our secant line, right? And then we talked about getting like f of c close enough to go ahead and give your derivative. But this was your rate of change, which is the same thing, remember, guys, as thinking of like your slope, right? The derivative was basically like identifying the slope, because that's what we're looking for, is the slope of a tangent line. Or in this case, we don't have a tangent line because we don't have an exact value, raised to 11. So what we're looking for is basically a secant line. We're trying to choose 2 points that is going to give us the best representation of a sub 11, because we don't have a time for 11, right? So we're basically looking for a secant line to give us an estimation. So you okay? Okay. So again, going back, we know that the derivative of v sub t is going to equal a sub t. So therefore, if I want to figure out what is a sub 11, what I can basically do is pick 2 values that I could find the change between that is going to be give me a good representation of 11. Well, the 2 closest values of 11 are going to be 12 and 10. So therefore, if I find the change in v sub 12 minus the change in v sub 10 over 12 minus 10, that will give me what the acceleration, that will give me that slope, right, between those 2 values, which will give me the acceleration at 11. Well, v sub 12 is going to be 30, and v sub 10 is 10. So a sub 11 equals 30 minus 10 over 2, where a sub 11 is going to equal 10 meters per second.